Solving trigonometric equations. It's a Leaving Cert higher level question. We've been asked in this example to solve the equation that sine 3 theta is equal to a half. It's in radians. I'm going to set the calculator in radians at the start, so I'm ready for this question too. There are an infinite number of solutions to this question because sine goes on forever and it's an open domain. We could find one solution quickly enough by using sine inverse of a half divided by 3. Input this into the calculator and we see pi over 18 or 1/18 of pi is one of the infinite solutions. Now where would we find the other solutions? One approach to understanding this question would be to consider drawing a graph of it in the real domain. The period of this function is 2 pi divided by 3 because the angle is 3 theta. The range is from 1 to -1. So I could quickly maybe draw a sketch of this. 2 pi over 3 is 120 degrees. So over 360 degrees or over 2 pi, we get 3 revolutions. This wave repeats itself 3 times. Now let's imagine where would the output be a half, even looking in this restricted domain here. So we can see it happens 6 times here, even in this. So we're considering where are these. It happens sometimes as the wave is rising up, and it happens sometimes as the wave is falling down. Now we know one of these answers already, but let's just consider the ones where the wave is rising up. We could see that this repeats itself every 120 degrees or every 2 pi over 3. So every period this repeats itself. And likewise, the other place where it happens as the wave goes down, this also repeats itself during every period. And this goes on forever in the positive and in the negative direction. We could see, just maybe looking at the graph here, that even by symmetry, that if we take pi over 18 from 1/3 of pi, we might be able to see where one of these angles happens, the first of them, and this gives us 5 pi over 18. So every 5 pi over 18, and this repeats itself every 2 pi over 3. So now we have the infinite solutions. There's the green solutions, which is pi over 18 plus n times 2 pi over 3, where n is any integer, any whole number, positive or negative. And then we also have the other one repeating itself. The 5 pi over 18 repeats itself every period. So that's the solutions. We could use the calculator to sort of check these solutions. It's easier to do this, and not in radians actually, but if we put the calculator back into the degrees. Now because pi over 18 is 10 degrees, and I can only take so many, I might just check even in a restricted domain going up to 240, and I could see the places where the output is 0.5, and I can see that this happens where we're projecting it at 10 degrees and again at for instance 170 and things. So that's one approach to this question. There is another completely different approach that I might just look at as well. If you let 3 theta equal x, so we could solve for x here. So sine inverse of a half gives me pi over 6, or 30 degrees if you wish. And I want to draw a sketch of this. So I'm not worried about the 3 theta yet, just imagine x. So we will get, there's 2 places in a revolution that we would have sine being positive a half. One is pi over 6, and the other we know what happens in the second quadrant. If we take pi over 6 from pi, that would be 5 pi over 6. So these are the 2 solutions for x. So theta then is, x is 3 theta. So if I divide this by 3, it gives me the theta solutions. So pi over 6 divided by 3 is pi over 18, and 5 pi over 6 divided by 3 is 5 pi over 18. We could double check that these solutions are correct using the calculator. So if I input sine of 3 times pi over 18, we should see that the solution to that is a half. And likewise, sine of 3 times 5 pi over 18 is also a half. Each of these solutions repeat themselves every period, every 2 pi over 3. So the general solutions are the infinite solutions to these equations, this equation. One of them is the pi over 18 repeating itself every 2n pi over 3, where n is an integer, any whole number, positive or negative. And the other solution is 5 pi over 18, which repeats itself also every 2n pi over 3, where n is an integer. I probably should clarify that n is an integer. So these are the solutions.